So now what is the heat produced by the electric current? We know that when there is a flow of heat through the conductor for a large amount of time, so definitely it will get heated. Yeah, so that is what we call as a heating effect. That is also we will say, so the heating effect of your electric current. So that is a heat produced in a resistor. Obviously when we say that, so when there is an increase in the temperature, so it gets heated, so the vibrations get increased. For that your electrons, so the amplitude of vibration get increased, so the definitely you can say that its resistance also is going to increase. Now we have to just find the heat produced. So definitely now this external source of battery has to do some work. It has to do some work to reach from one end towards the another end. Yeah, so that all the work done is nothing but, so some part of that will just generate in the form of heat. So let's say consider the example of your bulb. Yeah, so whatever energy that we supplied, so some of energy has been converted into light energy, but some part of that is also just converted into your heat energy. So now we have to see the expression for your heat produced in a resistor. So just we have seen that, so obviously there is a heat which is going to produced. So particularly for a case of resistors, all the energy supplied by that your external source will dissipated in the form of heat. Yeah, so we know, just consider that your Joules law. So we just generally define the potential is nothing but work done per unit charge. So work done is V into Q. So for this case of your resistor, so let's say this is the potential at point A, potential at point B. So just the charges has to overcome that resistance, so definitely they just spend some energy. So the potential at point B is less as compared to the potential at point A. So we can say that obviously this VA is greater than VB, or simple VA minus VB is greater than 0. Yeah, so this is how we can say that. So and all that work done will save in the form of energy. So this is work done, what you can say, this is UB minus UA. Yeah, so obviously this is less than 0. So that is the Joules law of heating. So obviously the conductor gets heated, obviously it has to, the charges has to flow through those resistance, it has to overcome the resistance, and because of which the heating effect will occur. So now what is this electric power? So the power is nothing but, obviously everyone is having the different power, means the rate at which we are doing the work. Yeah, so the power of let's say 100 watt bulb, the power of your 220 watt. Yeah, so likewise everyone is having the different rate of doing your work. Yeah, so the rate at which we are doing the work, yeah, by source of EMF in maintaining that electric current through a circuit is called as a electric power. So simple we will say that, so the power is nothing but the rate at which we are doing the work. Okay, so that is how we will define the SI unit of your power. Obviously we can say that it is your watt. Yeah, so for that your SI unit for your electric power, we will define the watt. One more we will think define over here, obviously for that joules heating. So we can write it down, the formula also. Yeah, so this is obviously that work done, which is nothing but your VIT. So this much of heat has been produced, or we can say I square RT, or we can say that, so in terms of this is joule, or again we can say that VIT upon 4.18 in terms of calorie also. So these are the different your formulas for that your work done in case of that is your heating effect.